Welcome to The Explainer. Today, we are diving deep, and I mean really deep, into a philosophical puzzle that is, believe it or not, half a century old. But what's so fascinating is that it feels more urgent, more relevant today than ever before. It all kicks off with a question that sounds incredibly simple, almost like something a child might ask. What is it really like to be a bat? But trust me, this simple question about a creature of the night spirals out and ends up challenging the very foundations of what we think science is, and it casts this long, haunting shadow over our future with artificial intelligence. It's a story about the limits of knowledge and the defense of our own inner worlds.
So let's start with a question that gets right to the very heart of the matter. A question about you. Is the feeling of being you, and I mean everything that makes you you, your private thoughts, the specific way you feel when you hear your favorite song, the comforting taste of a cup of coffee on a cold morning, the sting of a painful memory, the warmth of a happy one, is all of that, the entire universe inside your head, nothing more than a fantastically complex cascade of chemical reactions, a storm of electrical signals firing between neurons inside your skull? In other words, are you just your brain? It seems like a straightforward question, but how you answer it changes, well, pretty much everything.
Now, this question is part of the classic mind-body problem, a mystery that has been a playground and a battlefield for philosophers and thinkers for literally centuries. But for our story, we need to zoom in on the 1970s, because at that time, it really felt like science was on the absolute verge of declaring this ancient mystery solved. There was this incredible optimism, this powerful momentum behind a particular worldview that said, yes, the mind is the brain, and we can explain it all. So let's take a moment to set the stage, to really understand the intellectual world that the philosopher Thomas Nagel was about to walk into and, well, completely disrupt.
Okay, so in the middle of the 20th century, the dominant current of thought was that science could, and absolutely would, explain everything, including consciousness. This wasn't just one idea, it was a powerful intellectual zeitgeist. First up, in the 50s, you had behaviorism. Behaviorists essentially said, look, we can't see thoughts or feelings, so let's just ignore them. The mind is a black box. We can study the inputs, stimuli, and the outputs, behavior, but what happens inside is irrelevant to science. Then things got a bit more sophisticated. In the 60s, you get the identity theory, championed by philosophers like J.J.C. Smart. This wasn't just saying the mind and brain are connected, it was saying they are identical. The feeling of pain, for example, is the firing of certain nerve fibers, full stop. By the late 60s, this evolved into functionalism. This idea suggests that a mental state isn't about what it's made of, whether it's brain cells or silicon chips, but about what it does. It's defined by its function, its causal role in a system. And into this confident, progressing world, in 1974, Thomas Nagel drops what's been called a deep-sea bomb. His essay, What Is It Like to Be a Bat? It didn't make a huge splash on the surface at first, but its shockwaves have been reshaping the debate ever since.
So, before we get to the bat, we need to properly introduce the villain of our story, if you can call it that. It's not a person, but a powerful and incredibly ambitious idea. An idea with a very specific goal: to explain the mind and consciousness itself completely, leaving no mysterious residue, no spooky leftovers, no magic. This idea is called reductive physicalism.
Reductive physicalism is a big term, but the idea is pretty straightforward. It's the view that the mind isn't some separate, ethereal thing. It's a physical phenomenon, just like everything else science studies. Think about it like this. For centuries, lightning was this mysterious divine force. Then, science came along and discovered that lightning is an electrical discharge. The mystery was reduced to physics. Water was just water. Then we learned water is H2O. Physicalists believed, and many still do, that the mind would be the next great reduction, that a feeling like pain would eventually be fully translated into something like C fibers firing in the brain. The ultimate goal here was translation, to take all the messy, subjective, poetic language of the mind and convert it into the clean, precise, and objective language of physics and biology.
And you can see just how compelling this worldview was, right? It promised this beautiful, unified, complete picture of reality. Let's look at the core beliefs here. First, the world contains only physical facts. No ghosts, no spirits, no non-physical stuff. Second, the scientific method is the only path to real objective truth. And crucially, third, the path to understanding anything is to move away from your personal, subjective viewpoint, your feelings about it, and adopt a purely objective one. Nagel later called this the view from nowhere. This method had been unbelievably successful everywhere else. You break things down. A car is an engine, a chassis, wheels. A living cell is a nucleus, mitochondria, a cell wall. The mind, therefore, must just be another complex system. The most complex machine we've ever encountered, sure, but a machine nonetheless. One that we could and would eventually reverse engineer. This was the grand optimistic dream that Thomas Nagel was about to question.
And the way he questioned this grand dream is what's so brilliant. He didn't use a complex mathematical proof or a dense philosophical treatise. He used a thought experiment. A simple, elegant, and powerful invitation to just think. He asks us to set aside our own experience for a moment and consider a creature that experiences the world in a way so fundamentally, so profoundly different from our own. The bat.
So the whole argument hinges on understanding this fundamental difference in what we could call their operating systems. We humans, we run on a Vision OS. It's our primary input for navigating the world. We can describe the physics of it, electromagnetic waves, frequencies, cones and rods in our retinas, but the actual feeling of seeing the color red, that rich, immediate, subjective quality, is just a raw, direct experience. Bats, on the other hand, run on a sonar OS, echolocation. And Nagel chose them specifically because their primary sense is something we don't just lack, it's something we genuinely can't even imagine. They emit these high-frequency sounds and then build a rich, detailed 3D map of the world from the echoes, a map of distance, shape, size, even the texture and motion of a tiny insect in complete darkness. It's a completely alien way of perceiving reality.
Now, here's the thought experiment. Imagine that science progresses to its ultimate endpoint. We become the world's leading, all-knowing experts on bat neurophysiology. We have mapped every single neuron in the bat's brain and every one of its synapses. We understand the precise physics of the sound waves it emits and how they bounce off a moth. We know exactly how the bat's auditory cortex and brain process those returning echoes into a perfect, functional map of its surroundings. We have the complete, objective, third-person scientific account. We have, in essence, achieved the reductive physicalist dream for the bat's sonar system.
And this is the core of the entire argument. After all of that, after we've gathered every last scrap of objective data, after we can predict the bat's every move and explain its every neural firing, do we have any idea at all what the subjective character of that experience is like for the bat itself? Do we know what it feels like to see the world with sound? Nagel's answer is a firm, resounding no. We don't. And what's more, we can't. All our objective knowledge gets us to the very edge of the bat's experience, but we can never, ever cross over into it.
This quote from the paper brilliantly illustrates his new definition of consciousness. You see, he's not talking about intelligence or problem-solving or language. He's talking about something much more fundamental. He's saying that the lights are either on or they're off. An organism is conscious if there is something that it is like to be that organism, something it is like for the organism, from its own first-person perspective. If there's an inner movie playing, no matter how strange or simple, it's conscious. If there isn't, if it's like a rock or a coffee mug, then it's not. This simple, elegant definition completely reframes the entire problem away from behavior and towards subjective experience.
So the bat thought experiment isn't just a clever puzzle. What it does is reveal what Nagel saw as a fundamental, unbridgeable gap in our understanding. A gap that objective science, by its very nature, by its very methodology, might not be able to cross. Let's break down what this gap really consists of.
This distinction is really the philosophical heart of the whole explainer. On one hand, you have objective facts. These are the currency of science. A fact like water is H2O, is public, it's shareable, it can be understood from any point of view. You can be a human, a Martian, a superintelligent computer, the fact remains the same. The whole point of an objective fact is that the subject, the observer, has been taken out of the description. On the other hand, you have subjective facts. These are facts about what an experience is like, the feeling of seeing the color red, the taste of a strawberry, the bat sonar view of a cave. These facts are by their very nature essentially connected to a single point of view. You can't take the subject out because the fact is about the subject's experience. And this is the problem. The very process of making something objective, of removing the viewpoint, is to discard the essential ingredient of consciousness itself.
And this quote just captures that central conflict so perfectly. Let's read it again.
Every subjective phenomenon is essentially connected with a single point of view. Okay, that's the nature of consciousness, and it seems inevitable that an objective physical theory will abandon that point of view. That's the nature of science. So, to explain the bat's brain, objectively, science must, by definition, abandon the bat's point of view. But the what it's like to be a bat is the bat's point of view. You see the collision? The objective explanation will always, inevitably, miss the very thing we set out to explain. It's exactly like trying to capture the experience of listening to a Beethoven symphony by only analyzing the squiggly lines of the sound waves on an oscilloscope. You can have all the objective data in the world, frequency, amplitude, duration, but you will never, ever hear the music.
So what's the conclusion here? Does this mean science just has to give up? Is consciousness doomed to be an eternal, spooky mystery that we can never touch? Well, not exactly. And this is really important. Nagel's argument isn't anti-science. Far from it. It's a profound challenge for science to evolve. It's a call to recognize the limits of our current methods and a powerful defense of our inner world as something real and worthy of explanation.
So the big takeaway here isn't that physicalism is necessarily wrong, but that it is, at best, a radically incomplete story. It's a book about the universe that's missing the entire chapter on what it's like to be a reader. Nagel argues that this first-person perspective, this subjective reality, isn't just an illusion or a trick of the brain. It's a real, fundamental feature of the universe that needs explaining, not explaining away. He speculates, and this is where it gets really mind-bending, that we might need a whole new kind of science to do this. He tentatively calls it an objective phenomenology, a way to develop new concepts and a new language that can describe the structure of experience in objective terms, but without losing its essential subjective character. That is a truly monumental and perhaps impossible challenge. But it's a challenge he laid down for future generations.
And this is where this 50-year-old paper becomes just incredibly, startlingly prescient. Because the problem of the bat is the exact same problem we are going to face, and are already starting to face, with advanced AI. Just look at how this plays out. For the bat, we can know all its physical parts, but we can't know its inner world. For a fellow human, we make an educated guess. We assume their inner world is kind of like ours because they have a similar brain and they act like us. But it's still an assumption. I can never know if your experience of the color red is the same as mine. Now, for a future AI, we have the worst of both worlds. We will know its objective structure even better than we know our own brains. Every line of code, every circuit, every data point, but we don't share its biology, so the very basis for our assumption with other humans is gone. The barrier between their objective function and their potential subjective reality becomes an uncrossable chasm.
Let's walk through this because this is so important. Step 1. We build an AI that is behaviorally indistinguishable from a human. It passes every test you can throw at it. Step 2. This AI starts making claims. It says, I have feelings, I have an inner world, I'm conscious. Step 3. Now, we, as its creators, can do something we can't do with a human brain. We can perform a perfect black box reverse engineer. We can look under the hood. Step 4. We can trace the exact algorithm and find the precise data inputs that cause the AI to output the words, I feel joy. We have a perfect, complete, objective explanation for why it said that. And yet, step 5, the original question, Nagel's question, remains completely untouched. We know why the puppet strings were pulled, but we have no way of knowing if there's a real boy in there. Is anyone actually home? Is there something it is like to be that AI? Trying to answer that by looking at its code is like trying to feel the thrill of playing a video game by reading the raw binary on the hard drive. You're analyzing the mechanism, not the experience. It runs on a silicon OS, and we run on a biological OS. We can't run its software on our hardware, so we may never, ever be able to verify its claims.
So in the end, what is the lasting impact of this small paper from 1974? You could say that Nagel's work is a powerful, profound act of re-enchantment in an age that tries, and succeeds in many ways, to reduce everything to objective, quantifiable third-person data, to charts and graphs and metrics. He stands up and defends the reality and the ultimate value of our own private inner cosmos. He's defending the feelings, the sensations, and the experiences that can't be measured, that can't be put in a spreadsheet, but which are the very things that give our lives meaning.
And that brings us to our final, lingering thought.
The bat that was on the wall of a philosophy department in 1974 has now flown into the 21st century and landed right inside our servers. Nagel's question is no longer just a clever philosophical puzzle for late-night debates. It is quickly becoming a very real, technological, ethical, and maybe even legal problem that we are going to have to face, and probably sooner than we think. And the most haunting part of all, after 50 years of debate, we still don't have an answer.